2 days to do the last one, which is integration, and that gives us Friday to get ready for the final and talk a little bit about it. And Monday is an open day where you're given attendance for Monday, but if you want to turn up on Monday during this time slot, I'll be here anyway, and I can answer any of your questions, because you might not know what you don't know until after the weekend, then you suddenly realize you need help on something. So that's what Monday is going to be given for. So here we are, optimization. I love these questions. I love them for a lot of reasons. I love solving puzzles. So if you're that kind of person, you'll like these. And the second thing I like about them is they are a lot of different flavors of them. They're not just one puzzle question, and once you've kind of sussed out the strategy, all they do is change the numbers. No, there's a lot more to these puzzles than that. So here's our first one. I have to find two positive numbers whose product is 81. That means when you multiply them together, you get 81, but whose sum is a minimum. So that would be a fun a way of saying, can you tell me two positive numbers that add up to the smallest amount, but their product is always 81? So start by typically picking the two numbers, and X is going to be my first number, and Y I'm going to identify as my second number. I like X and Y. Technically, you could use any letter you like, but I like X and Y. Now, we are being asked to find the sum that's a minimum. So I'm going to make S be the sum, and the sum is X plus Y. Are you happy with what I've written down right now? I'm taking this English and I'm trying to turn it into variables in math, right? So X will be my first number, Y will be the value of my second number. So the sum is X add Y. And what else do I know? Well, I know that their product is 81. So I know that X times Y is 81. And that's important because this function here, right, the S equals X, S plus Y, right, that's very often got a name, and it's called the optimization function. Because that's the guy we are trying to optimize. We're trying to make it, in this case, as small as possible. This function has to be in terms of one variable. Right now, it's X add Y. And that's not good to us. It needs to be in terms of just X. And that's what this guy's job is. Because if you rearrange this, isn't Y the same thing as 8 over X? So if I tell you that is true, isn't this also true? Right? Divide both sides by X. Which means I can now replace
81.
81. Thank you. Well caught. So X add 81 over X. And that's kind of the first goal of many of these optimization questions. You want to get the optimization function in terms of X. In some questions, very few unfortunately, you actually are told this guy. And those are the easiest, because once you know this guy, how do we find out then when the sum is a minimum? Well, from our information, aren't we looking at tops of hills and bottoms of valleys when you do optimizations? In this case, aren't we looking for a low guy, right? But we know where those low guys live, don't we? They live at the critical numbers. So all I need to do is differentiate this function, right? Differentiate this guy and find its critical numbers. And that's going to be the answer to this problem. So if I differentiate this guy, I'll call it S dashed, you get 1. How am I going to write 81 over X so I can differentiate it? Because right now that's not helpful. How will I rewrite 81 over X so that I can differentiate?
81x to the minus 1.
Agreed. And now if you differentiate that, you'll multiply by the power and then reduce it by 1. And then if you do style points, you get that. Are you comfortable where the negative 81 over X squared came from? So here is my optimization function with only x's in it. I'm differentiating it to get that. And now I'm going to find my critical numbers. So I need to find when the derivative is 0 and when the derivative is undefined. The vast majority of answers to the PROSL is going to come from here. Very rarely, but 1 in a million, well, 1 in 100 is going to come from here. So let's do this one. I need to solve when is the derivative equal to 1. And the rules for this depend on what this looks like. If you can get this done algebraically and get an exact value, you should. If it's something ridiculously ugly, which you couldn't do, can you imagine it was sine x minus 1 over x squared, that kind of thing? Then you just go to Desmos and you get the decimal version. You'll know that you've got an exact value when the question doesn't say and give the answer to 2 decimal places. So if it says that, then you know you don't need to worry about solving this. It's going to be too hard to do algebraically. You just plug into Desmos, and you find out where it crosses the x-axis, and that's the answer, right? That's what we've got. But this one can be solved. As long as you do it to both sides, okay, Ro. Tell me what to do to both sides here.
Add 81 over x squared.
I agree. What do I do next? Does this help? What do I do
Cross
next?
multiply.
And that gets me x squared equals 81. So what do I do next?
Take the square root of both sides.
Right. Now, technically, shouldn't I say plus or minus when you do that? But weren't these numbers positive in the story? They said it right at the start, positive numbers. So I'm only going to pick 9. That, in fact, is the guy I'm looking for. So according to what we found here then, if I bring this down a little bit so you can see more of it, right? We have found the critical number x equals 9. The solution to these questions typically occurs at that value. So let's see what that looks like. Well, x is equal to 9. Won't y be 8 over x? 81, I should say, over x, which is 81 over 9, which is also 9. So find 2 positive numbers whose product is 81. Would you agree 9 times 9 is 81? And whose sum is a minimum. So the smallest sum that you could ever get in this story would be 18. Right? Let's check it out. I need a product to be 81, right? Well, couldn't I do x equals 1 and y equals 81? Would you agree they multiply together and give you 81? But if you add them together, would you agree that's a lot bigger than 18? So that's not the answer. Well, if I move up the food chain, couldn't I do 3 and 27? But don't they add up to 30? I've got a better answer, right? Where would I go next? I don't know where I would go next. Oh, well, I would do x as 9 and 9, which actually is the best answer. If I kept on going, I guess I could do 27 and 3, but that gets worse. Can you see it just grows towards the middle? And so we have got the best answer. Now, I could have checked undefined. This derivative would be undefined at x equals 0. Would you agree that's a non-starter for this puzzle? If I made one of the numbers 0, right? If I made x 0, wouldn't you agree 0 times something is 81 is really ain't going to happen, right? So you're normally going to get your answers from the critical numbers being 0. If you try to do this one, I think you'd say, yeah, that's not going to do it. That's probably an example of the absolute worst thing you could do, right? Because 0 plus infinity would not be a very small number when you add them together.
So the answer is y equals 27 and y equals 3.
Well, the answer was x equals 9, y equals 9. So let me show you what that would look like in the homework environment in WebAssign. Right. So there's the question I just did, question 1. And they want the answer in terms of a comma separated list. So you just do 9, 9. You tell me who x is, comma, you tell me who y is. So you just write 9, 9. Okay.
What was the y equals 27 and the y equals 3?
That was me trying out other examples just to show you that they're not as good as that guy.
Oh, okay.
Like, you didn't need to do those questions. I was just doing that as extra, right? So I got the next one. Find two numbers whose difference is 82 and whose product is a minimal. It sounds very like the question we've just done, but you can't always go by what things look like until you've actually written the math down and get a good grip to it. So I want two numbers whose difference is 82. And I want to make a product that is a minimum. This guy is going to be the optimization function. So I'm going to do x is my first number, and y is going to be my second number. And the product is a minimum. I'm going to call that function p, and it's going to be x times y. And if you tell me that the difference in the two is 82, right, then aren't you telling me x take away y is equal to 82? Does that make sense? If the difference in the two numbers is 82, then first number take away the second one is 82. Now, optimization function is this guy. Don't I need to convert it into only x's? So if we go over here, I want to take this piece of information and find out what y is in terms of x. Okay, so solving for y. You could do this all sorts of ways. How about that way around? Would that work? Subtract 82 from both sides and add y to both sides. You comfortable with that one? You want me to do it a different way? You'll get the same answer. Are you okay with that? Right, so what do you get? You get an x times an x take away 82. That's x squared take away 82x. So here is the optimization function. This is the guy you're trying to make as small as possible in this case, right? Optimization. So I'll differentiate it, call it p dashed, and I get 2x take away 82. And now I'll go looking for a critical number. I'm going to try and find for what value of x the derivative is 0, which means I'm going to be solving this guy, which if you add 82 to both sides and divide, you get that guy. There is only one critical number. Agreed? So isn't that going to be one of my two numbers? Right? X is going to be 41. So this guy up here is 41. How do I find out what the value of my other number, y, is? I know x is 41 because that's a critical number and that must be where the answer lives because there's only one of them and it's it. But how do I get y?
You know that y is equal to x minus 82.
And if I do that, I get 41. And in the homework they have two
negative?
boxes. Say again? It's not 41.
Negative.
Thank you. It's negative 41. So they have the smallest and they have the largest, which is fine. So the smallest number is negative 41 and the largest number is plus 41. And you might say that is a very big answer, but isn't it a very big negative answer? So doesn't that count as a minimum? Right. A very big negative number is considered to be very small. So although those two questions look superficially quite similar, didn't the optimization function come out quite different, right? This was a quadratic and the other one was a kind of fraction.
Is it always going to be just a split number like that?
Not necessarily so, although it's not that uncommon, right? It does happen a lot, but not all the time. In a way, it kind of makes sense. Would you agree if you were doing two things, a kind of balance between them is probably going to be the optimum, you know, like 30 would be split as a 15-15 kind of thing, or maybe a 30 and a minus 30 kind of thing. That's very common, but not guaranteed. You know, there are examples where that could change. So here is a version of question 4. We have a rectangle. So I'm drawing this guy. You're told its perimeter. And its perimeter is 84. And we were asking one whose area is a minimum. Right, so any rectangle in the universe whose perimeter is 84, you want to do it in such a way that it minimizes the shape. I could have a pretty decent guess that I know what this is going to be. Would you agree it's probably going to be a square? Right. But that's not proving that it's a square, right? Because who knows? A lot of things that we think are obvious, somebody, you know, comes out with a, well, you know, if you make it twice as long as it is wide, it's even bigger, right? You know, something like that kind of. So I'm going to go here and I'm going to start by describing the length as X. So that's that guy. And the width, I'm going to call that Y. Are we comfortable with my usual XY? This time it's going to be called length and width. And the optimization function is the area function. So that's going to be X times Y. We're good with that. The area A is X times Y. Now, this piece of information here is actually how I'm going to be able to replace the Y with X's. I'm going to switch over. If you add up the 4 sides, so you're being told that the perimeter is 84. If you add up all 4 sides, you get 2x plus 2y equals 84. And if you solve for y by subtracting 2x from both sides and then dividing everybody by 2, are you comfortable about how I got the y is 42 minus x property? Telling me the perimeter is 84 allows me to find y in terms of x. Have you getting a little theme here that the y has to be found in terms of x so we can go further? Because, now switch back, this function can't have 2 variables in it. It has to have just x's. And so this guy is 42x take away x squared. And if I differentiate this guy, it's 42 take away 2x. and I'm going to look for a critical number, which is when the derivative is 0. And that ends up being solve this guy. I'd add 2x to both sides. And there you go. This guy's 21 years. But how do I get y now? I know what x is. How do I get y?
Solve for the perimeter with x plugged in now.
Yeah, can I just use whatever it's, can I just use this guy then, because we've kind of solved already. So 42 take away 21, and guess what? What we predicted has came about. So any rectangle you could possibly have, won't the most efficient shape be a square? Right, most efficient, the biggest area. So if you were going to build a temporary fenced off area and you only had 84 meters of fencing, but you wanted to have as much square footage inside your fence, wouldn't you do a 21 by 21 square? And I bet you, if you know farmers, which I don't actually, but I bet if you knew farmers, wouldn't it be quite natural that they would just realize a square is the best shape, right? If you want to, you know, fence in some sheep, square's the guy. So I'm now going to change the story. We are going to have a river on one side, and the farmer has still got 84 meters of fencing, right? And we still want to maximize the area. This area, that, by the way, that should be maximum. Maximize the area. So it's the same story with one change. You only use 3 sides, because the 4th side's a river, and sometimes you use natural barriers, right? So you don't build fences. It could have been, couldn't it be the side of a shed, a big long shed he had, right? A hay shed. He doesn't need to build a fence on that side, right? I'm saying it's a river, but it's some blockage. Now, do you think you're going to get a different shaped square? Right? Is it still going to be a square or not? Let's find out. The perimeter, let's do it in order. The area is x times y. The perimeter of this fella is still 84 meters, but it's only made up of 2y plus an x. So if you subtract x from both sides, and then you divide everybody by 2, you get that guy. So the area is x times what we found out what y is equal to. Distribute with the x's. Have you noticed it's slightly different area formula, isn't it? Not a lot of difference, but enough to make a difference. Let's differentiate it. You get 42, take away an x, which if you solve for 0, can I do this one quickly and just say it's 42? But you can do it's an easy one to do in your head. 42. Now, what's the y going to be? Well, 42 take away a half of x. 42 take away a half of what x is. 42 take away 21 is 21. Which means that this is 42 and these two are only 21. Now, would you have guessed that if you are going to get the most area out of your fence and you've got a shed or a river or something that you don't need to fence, you actually make it twice as long as it is wide. That might not have been intuitively obvious. Can you imagine a lot of people would just turn it into a square again? Right, just divide 81 by 3 and say I'll make each side 27. And that doesn't quite work. Are we cool? So, oh, there's an example of it not being balanced, Rachel. You see, in this story, they weren't the same numbers. So a lot of the time they are, but not always. There are situations where that's not true. So I'm now moving on to a version of question 7. Well, I'll read this. There's a lot of story in here, so I'm just going to read it out. Consider the following problem. A farmer with 850 feet of fencing. So I'm writing that down before I forget. He has got a perimeter of 850 feet to work with, right? Fair enough. He wants to enclose a rectangular area. Okay, here's my rectangular area. And he wants to divide it into 4 pens with fencing parallel to one side. So he wants to break it into 4 pens. So basically, this is the configuration that he wants to build, right? He's separating out the males, the females, the female calves and the male calves, right? Whatever he's want to do it, he needs 4 different categories, right? 4 different regions. And we have to try and do this, right? To have the largest area. Okay, so it's still one of those fence questions, but again, a little bit different. So I'm going to do here, the length of the fence, I'm going to call it X. And I mean by X, that entire distance from here to here, right? That's going to be X. And obviously that's going to be X as well. I'm going to call the other side width again. That's a good name. And the width is going to be Y. And I mean, this guy is going to be Y. But actually, all these internal ones, don't they also use up fencing? So it's not just 2 X's and 2 Y's, right? It's a lot more Y's than just 2 of them.
Does it matter if it's in like 4 quadrants, like 2 on top and 2 on the bottom, or is it just rows?
Well, you could split it 1, 2, 3, 4 that way if you wanted, if that's what you're asking. The way the story says that they all have to be parallel, so they either have to go vertical, like in columns or rows, right? And that was part of what they told me I had to do. So I wasn't allowed to kind of, do 1 going this way and 2 going that way, right? That wasn't allowed. So in this configuration, at least then, that's my puppy. Can you hear that? God.
Gentle wailing of a puppo.
Yeah, God, it sounds like somebody's stuck a needle in it. Oh God, somebody's walked by the house. Okay. Hey, come on. Hopefully that'll quieten them down a little bit. Right, now, I need to figure out what Y is in terms of X, right? That's been every question so far, that's my goal. I'm told the perimeter, I've got this picture. So if I look at the perimeter, it's 850 feet. Maybe perimeter is a bad word, but I can't think of a better word. If you take 1, 2, 5, would you agree that you use 2 X's and 5 Y's to build this pen? And so that guy is eventually going to be able to get me Y equals, right? So think about solving for Y. So what should I do to both sides first? I want to eventually get Y equals down here somewhere. But what should I do first? What to both sides?
Subtract 2x.
That's what I would do. Would you agree then you divide everybody by 5? I'm not, well, I should be able to do it in my head. That's 170, take away 2/5 x. So A for area is going to be x times 170, take away 2/5 x. Are you happy about that line? How we
Okay,
go?
wait, so does
Gloria?
the perimeter, the one that's 850, does that include like all of the lines in the middle? Is that why you did
Yes.
5y? Okay, got it.
Exactly. Yeah. That's exactly what happened. So are we comfortable with this now? So once you've got your optimization function in terms of x, which is that guy, I can then differentiate it, which is not that hard to do. So far, so good. And now I will find critical number, which again is going to be a derivative at 0. So I'm going to have to solve that guy. Okay. What do I do to solve that guy? What do I do to both sides to solve that guy?
Subtract 170 from both sides.
Just rewriting up here. Okay, what do I do now to get x? What do I do to both sides to get x?
Multiply by -5/4.
Well done. Or divide by -4/5, which is the same as what you said. Yeah. So -170 multiplied by -5/4. And the answer I get is 212.5. Okay. Not the worst answer in the world. I was hoping something a little bit nicer. But 212. I also need to find out what y is, agreed? And if we go back to one of the guys that we did earlier, right? Wouldn't that guy there allow me to get what? So I'm going to go 170, take away 2/5 times x. So 2/5 times 212.5 and get the answer, a much nicer answer actually, 85. Now it could be that the question would just ask you to tell me what the length and width was, right? They could have said, just tell me the length and just tell me the width. And the answer would be 212.5 and 85. Would you agree that you probably wouldn't have guessed those numbers, right? And that you'd be there every day, you're right. But now the math is taking care of it. But that's not actually what they ask, although most of the time that is what they ask. In this case, they want to know what the area is. Well, don't I just multiply the length by the width? And it better be 18,062.5 because that's what this guy here says. So 212.5 times 85 is, and I'm doing a lottery today, 18,062.5 square feet. That's the answer that they want us to give in this question. Not what the length and width are, but what area would you get from that length and width? So can you see that you can do all sorts of puzzles with rectangles, right? as long as you tell me the perimeter. Any questions before I move on to boxes now? Puzzles with boxes. We feel cool? Right. So, this is question 8. Consider the following problem. A box with an open top is to be constructed from a square piece of cardboard 3 feet wide by cutting out a corner from each of its corners and bending up the sides. Okay. Drawing a picture of that. There is my square piece of cardboard. It's 3 feet by 3 feet. Even if it doesn't look it, pretend it is. You are going to cut out the same size corner here, 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 and here. Now, if you do that, couldn't you bend the sides up? And won't you get a box that looks something like this guy? And I'm amazed. That actually looks like a box because I'm a horrible artist. Would you agree that looks like an open top box? Can you imagine what would happen if you bent it along these dotted lines? These pieces here get cut out and thrown away. And would it bend to make that box? Okay. And we are being asked to find what size to cut these little square corners to make this, its volume, as big as possible. So the optimization is going to be the volume of this box. Now, the only thing that's unknown here is how big to make these little squares. They're all going to be the same size, so I'm going to call them all x by x. And if you want to find the volume, isn't it the length times the width times the height? Would you agree? And I want to know what the length, the width, and the height of this box would be in terms of x. So I'm going to move it over a little. Yeah, I'll move it down here. If you bend this box up, won't this be the length and the width? Agreed? Right. From there to there, well, the whole thing from start to finish is 3, but you're cutting an x out here and an x out here. Are you comfortable where 3 take away 2x came from? Right? 3, and then you cut an x and you cut an x, so the bit that's left is 3 take away 2x. Does that make sense? Wouldn't this distance here also be 3 take away 2x? Are you comfortable with that? So in my box, this distance here is 3 take away 2x, and this distance from here to here is also 3 take away 2x. So that's my length and width, right? The only guy I don't know yet is what the height is. What would the height of that box be if you folded it up?
X, length of
Agreed.
X.
Agreed? So what do we have? The volume is the length, 3 take away 2x, times the width, 3 take away 2x, times the height is x. Do you see that we've now got our optimization function and it only has x's in it, right? Length times width times height. That's, if you can get to there, the question's pretty much dead. By that I mean, it's pretty easy to solve. What I'm going to do now is FOIL this out. And so that's going to be 9 take away 12x plus 4x squared times another x. And now I have 9x take away 12x squared plus 4x cubed. I now have the volume in terms of x of this little box. And so I can differentiate it and get 9, take away 24x plus 12x squared. So far, so good. Now, find a critical number. Find when the derivative is 0. 9, take away 24x, add 12x squared equals 0. That's where we are right now. There's no mention of to 2 decimal places, so that means we've got to solve this guy. Anybody, this line doesn't matter too much, but for me it matters, so I'm writing it down. Shouldn't quadratics be written that way around? It just makes more sense, right? Okay, any suggestions to make this easier before we start thinking of factoring?
Take out a 3.
Yeah. So how take it out as a common factor, or just divide through by 3? You get this guy, you get this guy, and you get this guy. Interesting. Okay. It could have factored as a 4xx, but it doesn't. So it does factor as a 2x, 2x. Anybody want to tell me what combinations of 3 can be used here and here that generates a negative 8x? Would you agree they both have to be negative, right? Actually, that question's silly now, because I think there's only one choice, isn't there?
-1, -3.
Yeah. I can't see any way splitting it except 1 and 3, which gives us 2 possibilities. X could be a half, or X could be, what's that going to be? 3 halves. We've never came across a X equals a half before, have we? Well, 2 choices. Normally, don't you just have 1 choice and that's the answer? So I guess we'll have to figure out which one of these 2 is the one that gives you the biggest box. Let's take this guy. If X is a half, the length then is going to be 3 take away 2 times a half. The width is going to be 3 take away 2 times a half. And the height is going to be a half. And so that ends up being 2 by 2 by a half. So imagine a box 2 by 2 and half a foot high. Right, let's try this one. The X is going to be 3 take away 2 times the value of X. The length is 3 times that one. Oh, wait a minute. Would you agree that if the length is 0, you don't have much of a box? So there's our answer. X is a half. And when X is a half, you get a box 2 by 2 by 1/2. And they might ask you length, width, and height, but they didn't. In this question, they wanted to know what the area was. What the volume was. And the volume here is 2 times 2 times a half, which is equals to 2. And so you will put in that guy. So if you had a 3 by 3 piece of cardboard and you wanted to make a box with the biggest volume, you would make it 2 feet by 2 feet by a half. And you'd get that by cutting out half a foot out each corner. And we solved all of that by doing calculus. You agree? It's all algebra and calculus, derivatives. If I gave you that same puzzle, right, physically, here's 3 feet of cardboard, as many pieces as you like. I want you to make a box with the biggest volume. Would you have thought about a 2 by 2 by a half? Right. But now we know that is the best possible answer you could ever get, based on the starting information, what we have to work with. Perfect timing. Last name. And I'll see you tomorrow, where we'll do another day of optimization. We'll look at some more situations.
Thank you.
You're welcome. I'll hang about for any questions as always.